shared, my name is Alex Case, and I'm the Associate Vice President for Strategic Partnerships here at the Online Learning Consortium. On behalf of our Chief Executive Officer, Dr. Jennifer Mathis, and really our entire team, I'd like to begin by welcoming everyone to this second in an exciting series of new international webinars, which will extend from now through the early parts of 2022. Welcome to those that are live with us here in the session today first, and welcome also to those that will be watching this back in the future and engaging us with additional engagement opportunities as part of this ongoing conversation. One of the best parts of my role is supporting OLC's mission to expand and connect the community even outside the traditional spheres that we have operated in within North American higher education. We seek to be a contributor and a collaborator globally to positively impact online blended and digital learning. So for those who are new to the OLC, we were founded as a not-for-profit organization in 1999 and have been a self-sustaining and collaborative community of education leaders and innovators who are dedicated to advancing quality digital teaching and learning experiences to reach and engage the modern learner anyone, anywhere, anytime. Earlier this fall, we were asked to lead important research and community engagement in partnership with UNESCO IITE, the United Nations Education and Scientific Cultural Organization's Institute for Information Technologies and Education, and Shanghai Open University around the intersection of digital literacy, digital citizenship, and artificial intelligence. Today is the second of a 5-part series that complements case study research that is going on right now about best practices in those aforementioned areas of technology and education. So we're excited to connect you today with some of the brightest minds that we know from around the globe as we dive deeper into the components of these emergent and increasingly significant aspects of effective teaching and learning in the 21st century. Before we begin, I'd be remiss if I didn't thank some folks whose commitments have ensured our ability to connect today. Beyond our sponsors, UNESCO, IITE, and Shanghai Open, OLC is fortunate for the partnership and thought leadership of the International Center for Excellence for Innovative Learning, ICEFL, and particularly Vice President BJ Dungana, who is on our panel today. ICEFL's mission centers on personalized learning, refugee education, and innovation as change levers for the global good. OLC is also grateful for our friends at Fierce Education for a media partnership that has helped amplify our work throughout this webinar series. I'll introduce our panel participants in just a moment, but first a quick orienting point on how we find ourselves gathered today and speaking on today's topic of artificial intelligence. In leading up to this webinar and from collecting case studies around the globe as part of a forthcoming publication for UNESCO IITE, OLC created this conceptual framework, which you see on screen, regarding bridging the digital skills gap by promoting information and communications technology. The equity-focused practices of open educational resources adoption, understanding the application of artificial intelligence tools, the pursuit of equity through the advancement of accepted diversity, equity, and inclusion principles, and an unwavering commitment to the UN Sustainable Development Goal 4 become the 4 foundational pillars in our global efforts to master 21st century work skills, ensure digital literacy, and promote digital citizenship at a worldwide scale. In the lower portion of our framework, the developmental learning process for students is depicted. That process consists of acquisition, application, and creation of knowledge in connection with 21st century workforce skills, digital literacy, and digital citizenship. We know that access to digital infrastructure and skills, the development of digital literacy skills, and opportunities resulting from the mastery of workforce skills are essential to bridging the current gaps and improving education and economic opportunity worldwide. So there's no denying that those pillars are massive and worthy of a webinar series unto themselves. But as we seek to develop shared understanding of the key components and recommend essential actions that are scalable around the globe, we thought today's topic warranted special and unique attention and focus. Today's session is titled Artificial Intelligence and Disruptive Innovation. Helping us to contextualize and better understand this topic and its connection to the current state of global education are Dr. George Saltzman, Dr. Simon Maciejewski, and BJ Dungana. We also expect that Dr. Michael Torrance may be able to join us and share some insights as well. I have the privilege of telling you about them briefly, in a moment. But as we get to know our experts, just a look at the agenda for our time today. We hope to frame our learning and understand what AI is to start with, as well as understanding what the global challenge is and perhaps how that connects to the field perspective. We're going to save some time. We're going to aim to save some time for some questions that you can put into the Q&A panel of Zoom, as well as to upvote other topics that you're interested in through our conversation today. For those that are unfamiliar in Zoom, you do have some different view options under your menu bar, and we would encourage you to balance the look of the slides, which we'll be using for presentation purposes, as well as the faces, the pinned faces of your presenters today. So with us today, we have an amazing panel of folks that are really helping to influence OLC's thinking and research around this work. We hope to see Dr. Michael Torrance, but I'll come back to his bio once he comes in. I'll start with Dr. George Saltzman. Dr. Saltzman is an associate research professor in ed leadership and the director of the Center for Educational Innovation and Digital Learning at Lamar University within the state of Texas in the United States. But Dr. Saltzman has served as a contributor internationally to UNESCO policy guidelines for mobile learning, is the co-author of an administrator's guide to online education, and has authored multiple works focused on the integration of technology in education. He's delivered over 250 presentations on tech integration and has served as a consultant to numerous ministries of education, NGOs, and corporations during his academic career. At OLC, we're also fortunate to partner with Dr. Saltzman on much of our UNESCO international involvement, and he's been a key thought partner through this webinar series and our research right now. Next, Dr. Simon Maciejewski is the Assistant Director of Learning Technologies and Instructional Innovation at the Center for the Advancement of Teaching Excellence, located at the University of Illinois, Chicago. Simon is a code write and a gamification Sherpa focused on student engagement through learning analytics. With an open source award for innovative code development and a US patent pending in e-learning, he has been teaching online since 2003. Most recently, he was recognized with the National Award for Optimizing Student Experience. And for his work at the University of Illinois at Chicago, he was invited to the Blackboard Community Leadership Circle, which is a governance board appointed to lead and influence initiatives for the global education community. He also serves on the EDUCAUSE Student Success Analytics CG Steering Committee, which is putting out a lot of foundational insights to drive this work. And finally, BJ Dungana is the Vice President of ICEFL and leads an education consortium of 29 plus and growing European and African universities and non-governmental organizations dedicated to advancing use of technology in education for teacher training, which includes appropriate use of AI. He has over 20 years of experience helping education institutions achieve and implement their digital transformation journeys across Europe, Asia, and Africa. And in fact, since 2016, BJ has organized and led a number of education programs to expand use of technology to extend teacher training capacity in Africa, namely within Ethiopia, Kenya, Rwanda, and most recently, South Africa. BJ serves as the co-coordinator of the Teacher Task Force, working groups on education and emergencies and ICT and distance learning. When not leading in these global capacities, BJ is also director of Tablet Academy France and TA Benelux, a position he has held since March 2020. So if you can't tell, these are three very busy people with great international involvement. So I'll start by thanking them for being here today. BJ, I think where we might want to start is truly with you to help understand the global context to our topic today. And then from there, we can dive deeper into what exactly is this notion of AI and disruptive innovation. So in a moment, I'll ask you to tell us a little bit about how you see artificial intelligence and disruptive education impacting the education field. But first, to stimulate a little bit of audience participation, we did want to bring to you a few questions throughout our talk today. The first being, how many new educators does the world need to train and bring on board to meet the demand in the next 8 years by 2030? And we decided to use Slido for the quickest and easiest response here. If you're unfamiliar with Slido, you just open a new web browser and type in slido.com, and there's a number, 355797, which will enable you to be able to answer this question fairly quickly. So audience, let's see what the answer is. How many new teachers do we need? And then how might this connect to AI, which I think BJ is going to help us sort through. Responses are starting to come in. Let me give you a moment to log in and answer. A range here between 1 million and 70 million as our potential answers. coming on in. All right, let's take a look and see what our audience is thinking. Overwhelming runaway was 35 million, which is great, except that it's about half of what the actual answer is, which is 70 million, the highest of those numbers and options. So let me turn it over to BJ to help us understand this global context as a first reference point.
Thank you, Alex. Good morning, good afternoon, or good evening, depending on where you're connecting from. My name is BJ. As Alex said, I'm Vice President of ICEFIL, and I was a co-coordinator for UNESCO Teacher Training Task Force 2030 for 3 years until 2020. I wanted to share 3 things with you all today. One was looking at the key challenges in education globally pre-COVID, and then really share a bit about the devastating impact that COVID or post-COVID world. And then finally, I also, in terms of our webinar series and focus on AI, I thought it might be interesting just to get a snapshot of what teachers around the world are thinking about AI and where it could have an impact in their lives. It was done at the Strategy Lab in 2019, but I think most of their feedback are still relevant today. Okay. Okay, so pre-COVID is, I think, and what I'm sharing with you, I hope is not a surprise to any of you, but I think there is a mounting teacher crisis. And linked with that is a learning crisis globally. As Alex had shared, the world needs approximately almost 70 million new teachers by 2030 in order to meet SDG 4 goals. And what is SDG 4 goals? Is a right for all children and youth to have basic education. And I think what is frightening, and this is pre-COVID, is that 262 million children who could be in school are not, because they don't have access to schools or teachers. And they will add to the existing 750 million adults who are also illiterate. And I think we certainly believe that technology can and should play a role. But I think what I'm also seeing is that although the pace of digital transformation is having a very positive impact, it's also creating a global digital apartheid. And there is a growing exclusion within groups, villages, and countries, and at a very, very frightening scale. But I think I'm also pleased to say that despite its concerns, there is nevertheless a growing consensus that technology, and especially AI, must provide a potential solution to address this crisis. But that was pre-COVID. Now let's look at post-COVID. Yep, the situation's getting worse. The World Bank estimates that 70 million children annually will drop out. So this is in addition to what we had in pre-COVID, whereby approximately 6 out of 10 children globally will have no access to basic education. And the other frightening element is that we're seeing an increasing rate of teachers who are simply stopped teaching because of the pressures they're facing from school closures and remote delivery. So while we need more teachers, we also are finding that there are less teachers who are willing to teach. And the most devastating impact is that all of these closures will lead to an estimated 10 trillion in terms of, lost livelihood of our future generation. So I think for us, technology must play a role. And what I thought might be interesting for today and in the webinar series we're having is let's think about what the teachers are thinking about AI. And so what I've done is just grabbed a snapshot of some of the inputs that the teachers gave at a strategy lab we ran for UNESCO in 2019. Most teachers think that AI can help on the administrative side to help them reduce the burden, of non-teaching duties. And I think, today in a separate study, we find that nearly 40% of teachers' time currently is required for such duties. Secondly, I think they're also thinking that maybe AI can make the school administrative department smarter so that, they place less demands on the teachers. That's a very interesting concept. I think on the positive side is they're also hoping that it will help the teachers reduce the high dropout rate of students from schools. Remember, in pre-COVID, it was high. In post-COVID, it's getting worse. And certainly thereby reduce, the number of children who feel excluded from the education grid within, their communities. And finally, and this is the one I believe in passionately, is it to also support lifelong learning for vulnerable people to find a career pathway. And I think the goal is that they feel AI should empower teachers, but we should be careful that AI does not replace teachers. And Dr. Saltzman, I believe, will be talking a little bit more about on this area. But I think we also need to understand what AI is and AI is not. And I think a lot of the teachers from Asia and Africa certainly emphasize that we really need to have a formal policy addressing what is appropriate and non-appropriate use of AI in education. But I think everyone agreed that the real priority to make AI credible is we really need to show some immediate and practical benefits of AI to support teachers. Well, I hope that that's given a little bit of an insight into the global challenges. I think, in the chat section, I've put some additional questions where I would be quite interested to get your inputs, and maybe we can also have a conversation about that towards the end of this webinar. Thank you, Alex.
Thank you. From your introduction, an important area I think for us to dive into next is really an understanding or a bounding conversation about what is this AI in terms of education, what is it not? And we are going to look to both George and Simon to help us puzzle through that one. But first, another preceded question to see where your head and background knowledge and understanding might be of the size and scope of this notion of artificial intelligence in our daily lives right now, not even exclusive to education this moment. How many people interact with artificial intelligence on a daily basis? We have a range of numbers from the millions to the billions. So artificial intelligence is certainly growing, but just how large exactly is it and how present is it in our lives right now? So again, going to Slido, and with if you hadn't closed down that window, the question should be popping up on your screen. If not, you can open a new window for slido.com, and our participant code is 355797. Starting to see some responses coming in. Give you a moment to read, process, and answer. George, I know this is one of your favorite aha moments, so let's do the big reveal in terms of how many people are interacting with artificial intelligence on a daily basis. Our very brilliant audience got the correct answer, which is the largest, 4.55 billion. And everyone was, or a large portion of our audience was recognizing that AI exists in the billions at this point in time. So without further ado, let me turn it over to George and Simon. What exactly is artificial intelligence and what is it not in the present day? Understanding the bounds helps us question the role of AI and related disruptive innovations in addressing some of these most pressing global education challenges. I think BJ gave us a good sample of the volume and the needs and how COVID in some ways has set us back.
All right, thank you, Alex. You know, to put some context into that, the global population is about 7.9 billion. So, you know, if you rounded that up to 8 billion, that's about 65% of the world today interacts with artificial intelligence, largely through social media and largely through their mobile device. So the number of people that have a mobile phone that are connecting to social media, and through social media, they're having interactions with artificial intelligence. So artificial intelligence in the world today is absolutely something that's mainstream. More than half the planet is interacting with that for about 2.5 hours a day on average. So it is clearly something. AI in education and thinking about how AI in education works is not something that is brand new. We've been thinking about this for a long time. So I love the old idea of retrofuturism, where you go back in time and you see how people from a different time saw the future, and that kind of helps us see how we see the future within our own context. So now this is just a simple idea of a robot teacher. This was before people understood that the web would be there. So there's a bookshelf over there with I think those are tapes that would be loaded into the robot so that it would have that ability. So the next slide I love. This is one where they're predicting the future of the internet, right? Researchers thousands of miles away would be able to consult with books in the Library of Congress or the British Museum. And, you know, we do that every day, except I think the thing that they misunderstood was like books. Like books were bounding knowledge, and today we have knowledge that's sort of unbound. I think the idea of books is kind of quaint almost when we think about how we're doing research in academia. But there you go. So there was that one. The next one, I love this one. You're talking about man's intellect and intelligence being able to be increased by drugs and by linking human brains directly to computers. So you know, I don't know about what the ethics are about expanding minds on drugs in higher education. I'll leave that to the audience to chat in the chat window. I'm not going to go there. We're going to go to the next slide. There's a lot going on here. I love the way that this illustrates a certain model or a certain concept of what education should be. So this was the idea of what would education be when we could fully automate it, when it was all done with some sort of artificial intelligence. And in order to really completely understand this, I think you need to sort of zoom in to certain parts of it. So I've done that on this next slide here, where you'll see here is a student that got the answer wrong, and a robot comes and whacks the student on the head. So, right, we're going to make sure the students get things right. Here's another one. They actually have these things that are coming down from the ceiling to whack things on the head. But I want you to look at this little kid over on the right side. I don't know what he did, but somehow now we have this artificial intelligence thing restraining this child from learning by holding him captive over here on the side of that. So that is a very interesting and unique perspective about how we would enforce a certain model of education. And when I think about the use of artificial intelligence in education, I think that we always have to remember that how we imagine the classroom, the way that the formal education process works, is likely to change. So, and I hope that if this is the future of what artificial intelligence education looks like, it changes, because that doesn't look like a very fun thing for very many kids. Okay, so we're going to go on to the next piece and talk a little bit about what AI is in the scope of where we are, especially thinking about artificial intelligence in education today, and where AI is not. And the best way to describe that is in the industry, in the artificial intelligence industry, there's what's referred to as weak AI, or what is referred to artificial narrow intelligence. And this is the AI that you and I know. This is the AI that we interact with all the time. So if you've ever picked up a mobile device, or you've gone to Facebook on a web browser, you've interacted with AI. A human did not build those pages that you saw in your news feed. An artificial intelligence built those pages that you saw in your news feed. If you've ever said the words, hey Alexa, or hey Google, I can't say the other one because my thing over here will go off. You've interacted with an artificial intelligence. It's processed your human voice. It's understood the context of the question that you're asking. It's gone out, it's performed a query and brought a result back. That's a sophisticated algorithm, but it is still a narrow AI. And many of the times when we talk about artificial intelligence, we think about things like self-driving cars. And well, surely a self-driving car should be a strong AI, but it's actually not. Because the way that we define whether it's a weak AI or a strong AI is it equal to or surpassing the general intelligence of a human? So a self-driving car isn't going to have the same types of intelligence, the same types of reasoning, the same types of ability to contemplate problems and wonder what the purpose of life is. Strong AI is more of the kinds of things that we see in the movies. It's the type of stuff that we see being portrayed as these sort of intelligence that somehow have self-awareness and that are equal to or somehow maybe being seen as greater than what would be as a human. So many times, because artificial intelligence is just such a broad word, sometimes we start thinking about these robot teachers or these kinds of intelligences that we saw in some of those other pictures that are equivalent to what a human teacher would be. And this is not at all what we're thinking about when we're thinking about that in education. We're really thinking about very narrow types of specifications. So let's go into a little bit more of a understanding of how artificial intelligence plays out. So when we're thinking about artificial intelligence, there's some things, some different categories that take place. And like, for instance, reasoning and problem solving. Like, artificial intelligence is really good at being able to solve puzzles. It's really good at being able to play games like chess or Go. So anytime that we have some sort of puzzle where we need to make logical deductions, artificial intelligence can do that really, really well. Knowledge representation, that's a bit about like what you would see when we're working in Google's land and you're typing in query questions and it's bringing back answers. It's being able to make deductions about facts, process amazing amounts of data. We see this kind of thing in medical a lot, where it's looking at X-rays or CT scans or MRIs and making assumptions or predictions about what it sees. Then planning, how do we make sense of what's around us and how do we help use that to be able to make planning, learning through computer algorithms. And my colleague, Simon Matsujewski, will come in and talk a little bit more about exactly how machines learn in thinking about that process. When we're ever using these voice assistants, that ability to do natural language processing, but it's also being able to just look at the keystrokes, to be able to read and understand human language, to be able to understand the context of that, and to be able to form some sort of a question that can be put into a computer after it's been decoded from how we typically speak in natural language. You've got stuff that's dealing with perception, such as computer vision. This is where the actual decoding of the human voice is then put into the patterns that come into words so that it can then be fed into the natural language processing. So a whole lot about what we see about self-driving cars and that sort of stuff is perception. Where is this vehicle on the road? How do we understand how it's interacting with things that are around it? Motion and manipulation are used in robotics, the social intelligence to understand things such as human feeling and mood, which is sort of the big test that we see in science fiction. And then the idea of general intelligence, which is almost theoretical. It would take an enormous amount of power to be able to create an artificial intelligence that would have somewhat that general intelligence that we talked about when we talk about strong AI. So those are kind of the areas that you would see on a day-to-day basis within artificial intelligence. So what does that look like when we go into education? So we're looking at two major topic areas. UNESCO has done several studies on this. They've broken this into two major areas that we would see in the education space. The first is around this idea that promotes personalization for better learning outcomes. And that's looking at things like computer-assisted learning, which is a subcomponent of AI, that's providing personalized lesson plans or personalized trajectories, or it's providing some sort of individualized or what we often call differentiated instructional path for a student based on what they know and what they don't know. Okay, so this is the idea of hyper-personalization, individualization of learning on a one-to-one scale, much like we would provide that hyper-personalization or hyper-individualization of your social media news feed. You are the only person on the planet who got that specific news feed. This is the type of thing where we're looking at how does AI provide every student with a personalized learning plan that is unique to that student and the only person on the planet who has that very specific plan because of their unique learning needs. The second one, maybe I should even just talk about some examples of how that goes in. China has been doing a lot with that in that first topic area, thinking about how to learn English. So there's 600,000 students that are interacting with a program that helps them with English learning. In China, the same as in the United States, you know, the college entrance exams are a really big deal. There's a super teacher that's going through and helping students prepare for that exam and going through the process. Our colleagues down in Uruguay have done a lot of work with math. Here with Alex in the United States, Arizona State, and many others have done a lot of work with Alex in thinking about how to provide an individualized math learning program. The same thing that's happening in Uruguay at the K-12 level. Okay, so the second area is looking at data analytics and education management systems. So these are the back-end data systems that universities and systems look at to be able to track the type of student progress that we would see. And then you'll see that it's this evolution into the learning management system. And you're probably thinking, okay, well, I know what an LMS is. We've lived in LMSs for years. But I think this is really what we're talking about might be a true learning management system. I think when we're interacting with Blackboard and some of the in tools from like Instructure, those maybe aren't learning management systems. I think those are probably better described as course management systems. So how does this system know what I know? How does the system provide me with that individualized path inside something that's really about managing my learning as an individual student? So these types of things, which are being used widely now. If you look at the University System of Georgia, they're tracking student progress on every one of those students that comes in. They're using this type of data to make recommendations for how those students are progressing into the next courses that they take. What are the areas that cause first generation students to drop out? What are the things that we need to do to increase our first year to second year retention rate? How do we increase our graduation rates? Those are kinds of data pieces that are being tracked. We've seen this in a number of other countries. So our colleagues over in the UAE, who I see many are here today, have the UAE Ministry of Education has been working on this. Over 1,200 schools and 70 higher education institutions across the UAE have been working on putting this type of back-end data analytics together. It's looking at curriculum, it's looking at the teacher's professional development, the teacher's effectiveness in delivering a learning experience. So as an entire country, the UAE has been making great strides with this. The last data I saw, I think there's over 1.2 million students that are being tracked through this. This isn't something that is just within high resource countries like the United States or the UAE or EU countries. Even some of the what we would call more developing economies have been working in this. So in Bhutan and Kazakhstan, there's a lot of work now going on to try to make sure that the educational resources that are being deployed are being maximized by having an AI system on the back end to be able to move that forward. It's also looking at things as simple as where is the nearest school. So what BJ was sharing, about the need for 70 million new teachers. In many countries, schools are somewhat informal. They're not necessarily known. They don't necessarily aren't planned to be where they are. It's sort of where they evolve to be. And so you end up with gaps. You might have an area that is oversaturated with schools, and then you might have an area that's undersaturated with schools. And so UNICEF has been using AI to map all of the schools that exist in the world, and then look at where the population centers exist in the world, and identify areas where there are underserved populations to be able to try to drive that. All right, so as we're moving on, I think it's good maybe that we just touch briefly on some of the areas about what these disruptive innovations are. So we talked about artificial intelligence and disruptive innovations. This is coming from our colleagues at EDUCAUSE, who have sort of identified what are the disruptive innovations on the near horizon. So we're going to go through this in the speed round. Adaptive learning, which is having a learning management system that adapts itself to the needs of that specific student and provides the types of data and trajectory. We have some OLC Digital Learning Innovation Award winners at ASU and the University of Central Florida for some of the work that they did with Alex there. And every year we see more and more adaptive learning systems that are coming through and winning the OLC DLI awards. Next up, we're looking at open educational resources. From a developing country standpoint, this is amazing because now we have high quality resources, some of the best in the world, but they're available to everyone for free. It's not education on who can afford it, it's education to everyone. There are a number of OER repositories that you see there. The one that I love the most is the George Mason University OER MetaFinder. MetaFinder is an academic word for Google. You want to find something that's free, a textbook or some sort of a resource, you just go to the Mason OER MetaFinder MOM, put in your information, and it asks Google for the OER world. So next up, looking at gamification, game-based learning, and serious games, we are seeing more and more games that are learning. Gamification being how to bring game-based elements into classroom, like leaderboards and being able to win points or badges for some sorts of accomplishments that happen during the course. University of Michigan's been doing a lot of that. Game-based learning, there's tons of stuff that are happening in Minecraft and other games, Minecraft being the largest game on the planet. And there's tons of learning activities that exist now in Minecraft education. And serious games are things that feel like games that aren't really about entertainment as much as they're about teaching. So things like flight simulators and things would fit into those serious games. And they don't even have to be digital. Sometimes serious games are just tabletop exercises that take place in the classroom. Those are there. Online and massive open online courses. If you've been part of the Online Learning Consortium, you know that online learning has been a part of our world in higher education since at least the 90s, even before then. But Online Learning Consortium came in and really helped advance that. What makes this a difference is the ability to have artificial intelligence behind things like MOOCs. MOOCs they're great, millions of people enroll in them, but there's not a lot of interaction there because we don't have enough humans to be able to teach inside those. What if we had AIs? And what if we had things that could do the job like what humans would do? This was an example of a virtual teacher assistant called Jill Watson that was developed and put into a course at Georgia Tech that is now developed out where there's dozens and dozens of these virtual teaching assistants that are embedded in courses across Georgia Tech and others. And in many cases, they are indistinguishable from humans. At the end of the semester, there is a quiz or a study to guess which of your teaching assistants were real and which of your teaching assistants were virtual. And in many cases, students cannot distinguish between a real human teaching assistant and the virtual one. And that's the state of where we are and how that might be able to impact MOOCs, where we have these digital assistants helping where we don't now. Okay, so looking at mobility, mobile devices, and mobile learning. As we mentioned at the beginning of this session, mobile is giant in the world. We have about 5 billion mobile users by 2025, sitting somewhere around 4.2 billion, I think is what I saw for 2021. Almost every single person on the planet now has some sort of a mobile subscription. It is at the point of saturation. It's very, very hard for us to find someone on the planet who doesn't have a mobile subscription, and the ability for us to deliver learning through that mobile internet and through those mobile devices is off the charts. So moving on, blended and hybrid learning. Everyone that did any teaching in the pandemic understands that, but now that we have moved into blended and hybrid learning, we now have a place which the internet and technology and AI has a place to see what's happening in the normal classroom and all pieces and parts that can come in with AI assistance with that. All right. Last is, I think this is last, is looking at virtual reality, augmented reality, mixed reality, which is all within the big field of extended reality. Is there a place where we could begin to do simulations, where we can use augmented reality to be able to help us see things in the real world, especially thinking about vocational training? I'm not exactly sure how I'm supposed to fix this diesel engine, but I can now hold up my mobile device and it shows me the pieces and parts that I'm supposed to interact with in real time, or being able to practice things in simulation like surgery, which I hope get practiced on with virtual patients before they wheel my body in and work on it in real time. So that's an idea of some of the things that we see that are in the disruptive innovation space. AI and these technologies which are being enabled by AI sometimes seem like science fiction. It's very difficult to understand how in the world do we even get a machine to think. That's the part that often feels a little disconnected. So Dr. Simon Maciejewski from the University of Illinois, Chicago is someone who works in this area, and asked if he could provide us, how do we even make a machine think? Simon?
Thanks, George. Alex, just a quick time check. What's the expectation here as far as Q&As?
Yeah, and we are flying through this, but I'm so grateful for each of these contributions. I think BJ has really given us the why this matters. I think George has given us the what, and we'll actually use the last 15 minutes to close with the how. And then anytime we have left, we'll take audience questions. One of the things that we can do to make this experience last even longer than the hour that we have together today, audience, please put questions in the chat box or in the Q&A box. Anything that we don't actually get to live, we'll make sure that we get an answer as part of the closing materials. So that way we can maximize every moment we have. Simon?
All right, thank you, Alex. Yes, so really at the core of this whole new revolution is data. And to understand data, it is necessary to have power, to have computing power. And because of that, institutions that are investing in high performance computing really are going in the right direction. There, of course, are computing resources available through cloud providers and even machine learning systems. But those are really more of consumer level offerings. So when we start with the data, it's important to understand that the processing is going to take a lot. And of course, the largest computer today is mining Bitcoin. But if we do want to use computing for something more constructive, then certainly we would want to point them towards our data. Now, I do want to share in the chat here the University of Illinois Chicago's high performance computing system, because the 3,500 cores, the 24 terabytes of memory are being used for instructors to submit their data and then develop and adjust algorithms. And so those are basic skills that are part of data democratization. Now, this is an important concept because it means that we would provide access to data, that we would create governance, and also provide education. So data literacy, right? Not just digital literacy, but data literacy is so important. Be able to read infographics, be able to create them. What we see in this artificial intelligence concept is that we've taken statistics, which are magical. Some might say that you can prove anything with statistics. So there's a big component of misinformation, misleading, and so forth already embedded in that. But we've taken statistics and we put it into the world of computing, which basically scales statistics tremendously. And so what we see today, probably when we use the expression artificial intelligence, is a big hype. The hype being that you can sell more products if you put the label powered by AI on it. And so any type of statistical algorithm that is embedded in software oftentimes qualifies that in common speech to AI. And so that's where the hype is coming from. But there are some really key statistical algorithms that require our understanding, such as latent class analysis, where the statistical algorithm looks at the data and then brings up details about the data, patterns about the data that we have not seen before. So that is really an important point, that at the end of the day, artificial intelligence is processing data, very much image data, text data. Of course, with image data, face recognition, and all kinds of manipulation of images. With text data, we are able to use the natural language processing, which means that when you say something in many different ways, the computer can narrow it down to a single intent and then take that to the computing power and to request an answer. But beyond that, this is really sort of smoke and mirrors. So the images, the text, the power of artificial intelligence is that not only do we have this kind of understanding that's deeper, but we can push our knowledge forward through chatbots and the kind of a nudging process. So not only are we able to use statistics to prove different things and to find them, but now we're able to use Facebook to push those ideas and to make it appear as an army of people are speaking on the topic. And today, of course, we see that opinions are so divided. You know, it can start with opinions on pandemic or opinions on the presidential campaigns. And what we see in some of the research that was published is that the more people are educated, the more extreme they become in their opinions. It is as if the more education they get, the more weaponized, the more resources they have to prove their point, however extreme it might be. And so this is perhaps where we see this hype in AI happening, is that ideas can be pushed. And in education, of course, we hope that we can use tools to help students with the content matter. But overall, this should be a very simple process, but we, of course, are making it far more complex than necessary. Now let's go to the next slide. So we are talking now about some of the details of how this process works. And machine learning is a general concept. And we're saying that we can take data, we can then use the statistical methods, so very simple algorithms, and then apply that to produce some new knowledge. Now, this application can be in, of course, billions of operations, and it can be redone many, many times per second. And so what it means at the end of the day is that the computer can take time to look at all the possible options and then select the ones that perhaps are optimized by the programmer. And so we call that intelligence, but they didn't get it on the first try, right? So we would say that the person is intelligent when they get it on the first try, but they just basically kept repeating an algorithm until it completed the job. And so that's one method. There are other methods where people are able to perhaps guide the model, so make small adjustments, see the results, and then retain the one that produces 99% of accuracy. Now, we've seen this machine learning with those simple games that George mentioned. So the Go, the chess. And one of the similarities among those is that there's a clear win goal. So win state, right? So you know when you won in chess because the king has no other way to go and is being attacked. Or in Go, you know what the win condition is. And so this approach to machine learning works really well for those circumstances. Well, education is a little bit different, right? In education, the win state is not as clear. The fact that the students are passing the exams, is this a win state? Well, it turns out that in the US military, there was such a pressure in the nuclear weapons program for all the students to be passing exams, that they just introduced cheating. Everybody knew they were cheating. So in the no-fault type environment, people found a way to perform to that standard. So in education, we want to be very careful that we do not over advertise AI. For years and years back, we see where the radio was going to replace teachers. Later, television was going to most certainly replace teachers. And when VHS tapes came about, we suddenly understood that that's not going to happen. But then, of course, the adaptive learning on computers, or there are statements where even the laser discs were going to replace teachers. And so because this is simple computing, teachers certainly should not be afraid of being replaced. But it does work for repetitive tasks. So look at Duolingo, which is a language learning system, where it can use the principle of spaced repetition, where you introduce a new topic, then you quickly repeat it, then you repeat it a little bit later. And so that helps you to memorize that for a longer period of time. Those principles can be done through this system very well. Let's go ahead and go to the next slide. So as we consider the circular process here, Alex, can we switch to the next slide? Would that be all right? Thank you. So as we consider the process at the statistical level, and again, this is what people used to do. Now computers are doing that. The data analytics can be split into a number of sort of versions or evolutionary levels. The first level is descriptive analytics. So we are using data only to find out what happened. Now, if we were to study history, then the facts, the figures, who won the wars, that's the level of analytics. Then the diagnostics would be, why did it happen? So what events led to others? And then we can start teaching a class on perhaps not just memorizing facts, but also helping to bring insight, so understanding of why things happened. And then predictive analytics, these help us to try to apply the thinking of what if we change something, right? Can we have a different result later on? Can we predict something new? And then prescriptive, where we actually are able to write instructions. Maybe this is for the study of history. We learn what happened, we understand why it happened, and now we're writing a book for politicians on how to avoid these major disasters. So that's how data can take us to actionable level to the prescriptive analytics. Let's go ahead and move on. And so reporting, of course, whether this is through infographics, but most likely today we're pushing the data through the machine learning and what we call AI into other elements, such as chatbots, such as the voice systems. And we're trying to reach a place where we are now, of course, nudging people multiple times to change what they do. And so this is a nice graphic here that shows that the data is what feeds the process. Again, many problems already at this level. Is the data clean? Can we rely on the data, or is it garbage in, garbage out? Also, what data is missing? These are the key ethical problems that we're struggling with today, because really, just as there were papers in the past that were trying to prove that storks bring children, and they successfully published these papers. Why? Because it turns out that countries that have high populations of storks also have high populations of people, such as Germany and Poland. And so the causation and correlation were there, and the papers got published. And so today we see that with data, we are able to prove a lot of things. And so then we make it very, very successful on the other end of the machine learning it. So we see in some magazines today, AI being published as white man's problem, right? Why? Because many of the problems that were in the data to start with now have been scaled and deployed through AI. And so this is where we're saying that the learning happens. The learning happens when both people can correct the algorithms, but also algorithms correct themselves. And we're moving this forward. And I think the quote by Arthur C. Clarke is appropriate that says that any sufficiently advanced technology is indistinguishable from magic. I think we're in the place where we are creating what the games are calling an NPC or non-player character, right? This is maybe the guide at the gates to the castle that tells you what the next step is. And so these NPCs are going to be part of school. They're going to help students maybe enroll in the right classes. They're going to help students pass the classes. And yet there's a fear that we all have as human beings not to be an NPC. That's sort of the worst thing you can remember, to be sort of a just pre-programmed robot. And so we have to be very careful that as our students are working with the NPCs, that we don't start looking at students as non-player characters. And I think the relationship with students is going to be that elixir that's going to help us to sort of resurrect the idea that students are unique, that not all the same AI is going to reach them. And sometimes what they need are the human elements, and not just the knowledge and the nudges that the AI can do. Well, Alex, thank you. I think that's our final slide on that.
Yeah, and I thank you so much. I wish I had an hour for Simon, George, and BJ individually. Each one of these components of the what, the why, and the how, I think are really worth their own due attention. But thank you for pulling these things, these strands, and these topics together to give us a really bounded sense of how AI is impacting and may continue to impact, hopefully for the good, our entire education field. We did have two questions, which I'll make sure that we get time to provide an answer with. And one of the beauties and joys of this series is that we have natural points to make sure that we center those in upcoming sessions. We will take a pause after today through the new year and regroup in early January on a session focused on simulation, immersion, and gamification, which might be a great place to address a question that we got on what's the role of pre-service and in-service induction for teachers using virtual reality and AI. We have a session a week later focused on where do we go from here, really trying to go deeper into spending an entire hour delving into the ethical considerations of this futurism. And a great question from Dr. Hamdi came in. Panel has brought some interesting ideas and promising application. But what's really needed is some sound policy and procedure to bridge the gap between North and South, developed and undeveloped countries, considering the power economic condition in northern countries. And so I think we'll be sure to give that some attention and focus as we go forward. And then finally, we'll wrap up at the start of February by actually sharing out from the OLC team the recommendations and case studies that we've gathered as part of the OLC Research Center. So let me thank our awesome panelists for helping to introduce us and frame this topic today, for giving us some really amazing insights. And we very much hope to see you back as we continue this conversation. George, I'll let you have the last word, as I know we've been collaborating and you have some exciting resources of additional webinars, a course coming, anything you want to mention about some of the other things that we're doing in partnership with UNESCO on this front.
Well, looking at the questions that were asked, and I wanted to respond to those really quickly. So we had a question that came in that said, what needs to be done to educate teachers in pre-service and in-service programmed on VR and AI? That's something that UNESCO, Institute of Technology and Education, and Shanghai Open University have worked on. So there is a course that Dr. Macijewski and I have been working on to be able to prepare teachers to think about how to integrate AI into the pre-service and in-service training programs. How do we get that into colleges of education? There's another series of webinars that are being hosted by the Institute of Technologies and Education and Shanghai Open University that are dealing with that issue. And so I would love to point you to those, because that is the specific reason why those are being created, to help us think about what can we be done to put in that. And so Dr. Hamby asked what might be the $1 trillion question, or the $10 trillion question, if we look at the impact of COVID on the education space, which is what can we do to be able to help bridge the gap that exists between high resource countries and low resource countries in an international community. We often talk about that as the North-South divide. And one of this is a question that needs maybe a whole series of webinars, but one of the things that that Simon talked about during his thing is making sure that the data is clean. And we know that there's a lot of bias that exists in the data. We know that there's a lot of underrepresentation in underrepresented countries that exist in that data. We need to do everything that we can to invite our colleagues who are from the from the South, from less developed countries, to participate with us in the high resource countries where a lot of these technologies are being developed. They need to have equal representation. I think there should be many, many opportunities for people to come and work in the research labs and be able to work in the cutting edge where this stuff is there, so that they can bring their perspectives, they can bring their cultural representation, and they can ensure that they are being equally represented, especially equally represented in the data that's being used to feed into all of these AI systems. The other part is, I think this is already, I'm very encouraged by a lot of the work that's coming out of the UAE. The Hamdan Foundation has already done a lot to try to close this gap, to provide the financial resources to help bring some of that together. BJ has worked very closely in that organization, and I know Dr. Hanby, you have been very involved with that too. I think we should, from my perspective, I really love the idea of charitable resources or philanthropic resources going into trying to close the financial gap that exists between high resource and low resource. So that's, Alex, that in in 30 seconds or whatever that was a lot to cover, but I hope that we gave at least some representation to the need to have all people represented in the development of these technologies and the financial resources to ensure that we do not continue to inadvertently widen the digital divide.
Well, big topics need ongoing conversation, and I'm excited that we have this platform and this community space to talk through them. We will connect everyone with the additional webinar opportunities and information about the course through the same ways we advertise this webinar. That everyone gets access to the resources mentioned in this session and a copy of the session and the slides. Thank you all, and have a great rest of your day.